Hi students, welcome back to another lecture video. We're going to start today with a discussion about something that I ran into a little while ago when I was baking something. The recipe called for 1 tablespoon of salt, and if you look, there's a big T right here with 1 tablespoon, and then over here the little t means that this is actually a teaspoon. Don't ever get those mixed up, by the way. I only had, at the time, this one was in the wash, so I only had the teaspoon. Well, they're clearly not the same thing, but, you know, how many teaspoons go into a tablespoon? Maybe I could just use the teaspoon. Hey Siri, how many teaspoons in a tablespoon? Okay, 3 teaspoons. So with that much ease, I can figure out what's called the conversion factor between teaspoons and tablespoons. And, simply just measure 3 equal teaspoons, and it should equal the exact amount of a tablespoon. They are the same number. That should make sense, right? We do those things all the time. And I use that example because today we're talking about this concept called dimensional analysis. And that's a big sounding term, but really all we're doing is converting between units or measurements. So you've done this your whole life between, distances, especially like inches and feet, seconds and minutes, and like we saw with cooking, measurements and volumes and things like that. You know how to do this, but there's some more tricky ways to do dimensional analysis that in chemistry we use that are a little confounding for students and difficult. So what we're going to do is break down a simple step-by-step way of going through dimensional analysis with some problems. The first one is going to be pretty easy, and the next one is going to be a little harder. Let's start off with a vocab word here. The word is conversion factor, okay? So a conversion factor is basically a ratio that helps you convert between units. Now, don't let the word ratio scare you. You've used ratios your whole life, I promise. Let's try with an example here. If you had a classroom with 10 boys and 20 girls in that classroom. Let's say I had a class of 30 and 10 are boys and 20 are girls. What's the ratio of boys to girls? Maybe that's still a little confusing. I'm basically saying how many boys to how many girls in the class. You might say, well, it's 10 to 20. That's true, the ratio is 10 to 20, but we usually like to do ratios in the most reduced number possible. And the best way to write that is 1 to 2. So 1 boy for every 2 girls in this class, right? So you've used ratios before, 1 to 2. Well, in chemistry and with conversion factors, really just in anything in science and measurement, we have lots of different conversion factors. In fact, however many units there are, there's basically, as long as they're in the same kind of unit, like time or distance or volume or temperature or something like that, there's a way to convert between them. So I've just listed 5 random ones here because, just to give you some sort of bearing on the idea of conversion factors. I've written down here, it's called a unit equivalency. Now, what I mean by that is this unit is equal to this many of this unit. This ratio. So the ratio of 1 tablespoon to 3 teaspoons, 1 to 3, is equivalent, meaning they are the same number, but they just, are measuring using different quantities. 60 seconds is a minute, 60 to 1. And that number 60 seconds is exactly a minute, by definition. 7 days is a week, and 12 inches is a foot, and 4 quarts is a gallon. Those aren't estimates, those are exact values. And here are their ratios. Let me put it in a slightly different arrangement here and show you the way that we'll write it out in chemistry. And I've sort of just done the lines here to sort of show you, which ones go with which. A tablespoon is equal to 3 teaspoons. And the way I can write that is 1 tablespoon over 3 teaspoons. I could have actually flipped those around. Here's why. All of those numbers are basically putting 1 over 1, which of course equals 1. And I can put 1 over 1 either way. It's the same thing in a fraction. What I mean by that is this number is the number 1 tablespoon, and this number 3 teaspoons is 1 tablespoon, just written in a different unit. So it's basically, even though the number is 3, it really is the number 1 in tablespoon units. And because of that, it is the same as writing the number 1 over 1 as a fraction, which is just the number 1 anyway. And if you times or multiply or divide the number 1 to anything, you've done nothing to it. So I can convert between different units and not change really anything in the math other than the units I'm using. This is just the logic behind it. So all of these different conversion factors here can be written this way or written upside down, right? I could put 3 tablespoons on top and 3 teaspoons on the top and 1 tablespoon on the bottom, and it's the same thing. 60 seconds over 1 minute or 1 minute over 60 seconds. Those are ratios that you can put either way. It doesn't matter as long as you keep, the number and the unit together. You couldn't put 60 minutes to 1 second. That doesn't work. That's not true. So these are conversion factors. We're going to use conversion factors to do some unit conversion. I'll show you coming up next. So before we do our first problem, let's do a step-by-step how to convert system, right? These always are helpful for trying to do something new. Is just go by a system step by step. Here's the first step. Start with what you know. Okay, what that means in any given problem is the number you're given should be the first thing you write down. I'll show you how to do that in just a minute. Step 2, think where you want to go. Those happen to rhyme, not really on purpose, but still fun. Think about where you want to go. So I want to go from this unit to this unit. How am I going to do that? Step 3, write the conversion factor so the units cancel out. Okay, I'm going to write the units and the conversion factor so that the units are going to cancel, and we'll show you how to do that. 4, calculate the answer by multiplying the top numbers and dividing by all the bottom numbers. And then lastly, I'm going to consider the answer and to think if it makes sense. So I'm going to look at the answer and say, does that make sense or does that not make sense mathematically? Does that look like a good number? Let's show you with a problem as an example. The first problem is going to be, how many seconds are in a 49-minute period, right? So in a 49-minute period, a short day, how many seconds are actually in that time? The way that we're going to look at this first is I'm going to start with what I know. 49 minutes. I'm going to write that down first. It's good to know unit abbreviations, by the way. MIN for minute, SEC for second, and other, of course, abbreviations that go with other types of units. 49 minutes. Now I'm going to think about where I want to go. I'm trying to figure out how many seconds are in that 49-minute period. So I'm trying to convert from minutes to seconds. The way I do that is by converting. So to go from minutes to seconds, I'm going to use this particular conversion factor right here. There are 60 seconds in 1 minute. I'm going to multiply by that conversion factor. 60 seconds in 1 minute. But here's the question. Do I put 60 seconds on top or 60 seconds on the bottom? Remember I said I could put it either way. So 60 seconds in 1 minute is my conversion factor, but what order do I put it in? Well, I need to write the conversion factor, step 3, so that the units are going to cancel out. 1 minute, 60 seconds. Now, why did I do it that way? Because if you remember in math, if you got something on top of a fraction and on bottom of a fraction, those two things can cancel out mathematically. If you don't know that, that's okay. All you need to know is that basic rule, that if something is on top, you can cancel it by putting it on the bottom. And because these numbers are equivalent, 60 seconds and 1 minute are the same, I can put them either one on top or on the bottom, but I want to make sure to put it in the right order so that the math will work out later and that I'll actually be canceling units, not making the problem worse. So minutes are going to cancel. So I'm going to cross them out with my pen. Seconds doesn't cancel because there's no seconds on bottom. It's just seconds on top. So now I'm just going to do step 4, where I'm calculating the answer by multiplying those top numbers and dividing by bottom numbers. So the first number here is 49 minutes times 60 seconds. Now, you might wonder, how do I know that this is a top number? Well, I put a 1 underneath of it just to dispel any idea that this might be a number that should be divided. It is a top number, though, because the number 49 minutes is not a fraction, 1/49th or something like that. The number started off as a whole number, and any number like that is just that number over 1. So kind of always assume that first number is probably going to be a top number or a numerator. So the next step is just to multiply them. 49 times 60. Those are my top numbers, 49 times 60. So now my number is 2,940. Do I need to divide anything? Okay, anything on the bottom, divide by the number 1. That doesn't do anything. Again, divide by the number 1. That does nothing. So if you've got the number 1 in the denominator here, it's not really going to do anything to your answer. But if these were bigger numbers than the number 1, I would get my answer changed. So the answer is 2,940 seconds. And then the final step is to consider your answer. Does that answer make sense? And let's think about it. Does this answer make sense? I started off with a small number, but a big unit relatively to a second, right? A second goes by like that. That's a small unit compared to a minute, which, I gotta wait a little while before a minute goes by. I'm not gonna do that right now. So a minute is a bigger unit than a second, right? Just like an inch is a smaller unit than a foot, or, a gallon is a bigger unit than a liter or a milliliter or something like that. So knowing which unit's bigger, and then as I converted from a big unit to a small unit, I'm going to get a bigger number because I need more of those little units to equal out the big unit. So the 2,940 seconds, that makes sense, and it passes the test. Okay, let's move on to another problem. This one a little harder. How many inches in a mile? Pretty interesting, right? You probably run a mile in PE before, and it's hard, right? But if we're not to think about that in feet, but in inches, there's going to have to be quite a bit of converting here. So first thing I'm going to do is just list out some conversion factors, some known numbers for us to consider. And then we will do the conversion. First off, the conversion factor of going from inches to feet. 12 inches in 1 foot. And you could look these up, right? If you didn't know them. And then how do I get from feet to miles? There's 5,280 feet in 1 mile. Again, you could just look those up if you didn't know them. So let's convert first. Start with what you know. In a mile, 1 mile, I start off with 1 mile. And now I'm going to convert the miles to inches. Where do I want to go? I want to go to inches. I don't have a conversion factor for the going from miles to inches. There probably is one, but I didn't look it up, and I don't know what it is off the top of my head. I would just use the ones that I knew. And I do know, I have these memorized. So let's go from miles to feet, and then I'll go from feet to inches. So first, let's put the miles down here. 1 mile is 5,280 feet. Now remember, I had to put it down at the bottom so that it would cancel. So miles are canceled. Now let's move to inches. One of the cool things about conversion factors is that you can just keep lining them up, and as many as you need, you can just keep going until you get to the unit that you want. So now I'm going to multiply to get the feet canceled. I'll put feet on the bottom, 1 foot. I'm using this conversion factor right here. 1 foot is 12 inches. So now feet are going to cancel. And now I just multiply everything that's on top. So 1 times 5,280 times 12. 5,280 times 12 is 63,360 inches. Okay. So a slightly longer problem that you need to do a couple steps in order to solve for the final unit, which would be inches. Now that is the basis of dimensional analysis. It's not super difficult, but when you get to units that are going to be new, something like a mole or a mole ratio or something that we're going to deal with in chemistry, this same process we use, but we're going to use new units that you're unfamiliar with and new kinds of conversion factors that maybe you haven't heard of before. So we'll use that same principle, but with concepts related to chemistry. I hope that was helpful.